Hi there. Welcome to Graphing with MATLAB, which is part 3 in Appendix C of Stevens's Matrices, Vectors, and 3D Math, a game programming approach with MATLAB. I'm going to open up a couple of files that are found in the code repository with the textbook website under this group of zipped files, a quick guide to MATLAB. So just a little preview of what's coming up. I've broken this chapter, this particular section of this chapter, into 3 parts. This first part, the one we're going to do in this video, is we're going to look at the plot command. And you can use that to plot y as a function of x. You can also use that plot command to plot x and y are both functions of t, another parameter. Right? Those are called parametric curves. The second video will be on how to create animations, and then the third video will contain these 2 methods for plotting in 3D. There's plotting surfaces with the surf command and curves with the plot3 command. Alright, so for now, we're going to start with the plot command, and I want you to grab a couple of files out of the program repository under the Appendix C zipped collection. Right, so let me open those up. The ones you're looking for are example plot, and then the other one is example parametric plot. Right. So in both of these cases, I'm going to demonstrate both of them in detail. So this first one, example plot.m. What I want you to do first is just run it. All right, so once you get it open, you run it. And the way I have this tabbed, my figures are over here. So they actually did show up. I just have, just for the sake of displaying all this in one screen, I have my code in one tab, the figures in another tab, and the command window in the other. It sort of saves space. I don't usually work with MATLAB in this format because I like to see everything. But as far as putting onto a video, I find this way works best. Okay, so just once you run it, and your graphs will just pop up. Mine are over here. Now what we've done is we've done a couple of curves. Here we have a cosine curve and a sine curve in red. And here we have a sine curve and a cosine curve, and just some more bells and whistles, a specific point, how to label these things, use different graphing styles, stuff like that. So let's see how I did this, right? We'll worry about this first graph on the left. 2 curves, a blue cosine curve and a red sine curve that's a little thicker. Okay, so the way I start this off, I always start off my codes with CLC and CLF. This clears the console, lets you start with a clean slate. It's actually called the command window, right? So that clears the command window, and CLF clears the figure. So if you had any leftover figures, it clears them. And then I'm going to create this is the, let's see, this is the x values, right? So when you look here, these x values down here, I'm going to go from 0 to 2 pi, right? So I'm going from 0 to 2 pi. I'm going to create 100 points, equally spaced, starting at 0, ending at 2 pi. This linspace, I mean, you could create this with a for loop, with some other methods, but this is probably the easiest way with the linspace command. And then y1 will be the cosine of x, and y2 will be the sine of x. Right? And notice over here, one of these is blue. Right? Cosine is blue with thin, and sine is red with thick. So how do we do that? The first thing we do is we use this subplot command. Right? And this means it creates, it's a whole sequence of functions, really. First thing it does is it creates an array of plots, a 1 by 2. So 1 row, 2 columns. It's going to create two plots, right? And this one that we're working on is the first one, right? Create the first of a 1 by 2 array of plots. And so the first plot will be x. Use the plot command. There it is. We'll plot x, the x values, and y1, which is cosine x. And this without any bells or whistles. We're not defining any styles or sizes. And I'm going to do hold on because I'm also going to put another graph in there. I don't want to erase the first. And then I'm going to plot x and y2. That was the sine x. But for the sine curve, the y2, I want to make sure it's red, and I give it this line width, comma 3, right? And so this 3 will actually make it thicker. And then I put in a title. All right, title is enclosed with single quotes. And by the way, as I'm going through this, there's no way you're going to remember all of these things. Just remember that what you can do, and then realize that you can go grab the appropriate code from the repository to get the exact syntax. You're unlikely to remember the exact syntax. Right, so this group of commands right here created this plot on the left. All right, so let's worry about this plot on the right. Notice we have dots, blue dots that are squares, black open circles, and then a big green dot at this point, pi, sine of pi, x label, y label, and a title. So we got a lot going on. What happened there? This is all subplot 1, 2, so that's the same array, a 1 by 2 array of plots. Now it's working on the second one. Now it's going to plot x and y1, right? That's the cosine with the blue dot. Hold on so that it doesn't erase when it creates the next plot. You're going to plot x, y2 with a k. That k stands for black because b stands for blue apparently. And then that's just a small o, right, for circles. And then, so that gives me my two curves, right? That gives me the cosine curve in blue dots and the sine curve in black circles. So how did I get this green single point on the curve? We use the same command, plot, right? And I got to put these in brackets because it's expecting an array of x values and an array of y values. So to put them in array format, we put square brackets around them. So I'm going to plot the point pi sine of pi. I'm going to make it a green dot. I'm going to make the marker size. If you didn't put marker size 30, you'd barely be able to see it. I'm not sure what the default size is, but 30 is at least a lot bigger. And so that created this big green dot. And then I do title, creates a title. And you can use this pi, you can get pi in your title by doing \pi. And an X label for creating an X label, Y label for creating a Y label. You can define the font size if you want to make it bigger. And then this axis tells me what my axis bounds will be. So basically it goes X min, X max, Y min, Y max. So I'm going to go from 0 to 2 pi on the X axis, negative 1.1 to 1.1 on the Y axis. If I got rid of this, if you go back and you look at this, so there's what that curve looks like. If I got rid of that little axis, let's see what happens. Right, and then I run it. Right, notice it goes out to 7 because it wants this axis to look good. Right, and so you can define the exact bounds on your axis with the axis command. Right. Okay, so that's the plot command. Basically, the usage is plot parentheses the x vector and then the y vector, which you've hopefully created before you get to the plot command. And then separated by commas, you can add some other directives. Okay, so the second plot I'd like to go to, plotting technique, is called a parametric plot, but we're going to use it with the exact same plot command. Again, I clear the command window in the figure. Now if you notice, let's run it. Let's run it first. So parametric plot, example parametric plot. You run it. It actually has two separate figures as opposed to two graphs in the same figure. So I'm just going to dock this right in with the other. So now I actually have figure 1, figure 2. Right? Okay, so what you can see is I'm doing a couple of, this is actually a circle, this is an ellipse, right? And so what I'm doing is I'm going to do parametric plots for circles and ellipses. So the first thing I need to do is create my parameter. That's why it's called a parametric plot. T. And that's going to be a parameter that goes from 0 to 2 pi, and I'll have 100 points in there equally spaced. And then my circle with radius 2, centered at 0, -4, looks like this. So there's my x values. There's my y values. And then I'm going to create an ellipse centered at 3, 2 with x radius 1 and y radius 4. And so that 1 and 4 comes out in front of 1 in front of the cosine, 4 in front of the sine. So that's what makes it non-circular, and it's centered at 3, 2. Right? Okay, so to just plot these, now I'm going to create two different figures. The first figure, I just do figure 1, plot x1, y1 with a with a black circle. Hold on, because I'm going to plot another one. And I can put some text right inside the actual graph with this command. It's just called the text command. You put in the location and what you want to put in there. All right? As well as the alignment. And then the next plot within that same figure will be the ellipse, x2 and y2. All right. We'll do a red line for that, line width 3, and then I can put some text in there as well. So I'm basically making sure that, let's see, I'm labeling my circle as a circle, and I'm labeling my ellipse as an ellipse. And then I throw a title in there. And so that first plot is this one right here. But notice, MATLAB had its own scaling to make sure everything fit nicely. And what it did is it made my circle look like an ellipse, and it made my ellipse look a little more circular. So we'd like to avoid that, right? If we want a realistic depiction of circles to look circular, we need to correct for this. Okay, so the way we do that is in the second figure, we do the exact same thing, all the same stuff, only at the very end, we do axis equal. Right? You got to do that last, because if you do axis equal and then change maybe an axis or add some more plots, it might skew it again, right? Or scale the x and y axes. And so the second plot looks just like the first, only I have the command axis equal, and notice what that does. I get to my second figure. Now my circle is a circle, and my ellipse is an ellipse. There's a lot of white space, but at least my circles are circular, right? That's why the whole scaling that MATLAB automatically does is just so that the graph takes up more of the window. So when you make the axis equal, so you get realistic depiction, sometimes you get a little extra white space. But that's okay, because I want my circles to look like circles. Alright, so that wraps it up. That's the plot command, and either way, whether you're doing a regular plot as a function of x, y is a function of x, or if you're doing a parametric plot where x and y are functions of another parameter t, it's the same usage. It's the word plot, the x values, the y values, and then some directives. Alright, so that's round 1. I'll have 2 more videos for this particular chapter. Bye.